Okay, this afternoon we're going to be looking at expanding and condensing logs. First problem I'm going to look at is number 81. We're asked to take this expanded form and condense it to a single log. So in the very end I'm going to end up with natural log of some number. Now one thing I'm going to kind of stress with this problem is I'm going to distribute the -2 to each of these. So I would rewrite that as ln of x minus 2 ln of x plus 2. Do not distribute through, it's just 2 times the natural log, and then -2 ln of x minus 2, like so. Then we're going to carry the exponent up, and I'm just going to carry the 2 and leave the negatives. And if I do that, I will have ln of x minus ln of x plus 2, the quantity squared. I'm not going to square that. That would require distributing or FOIL. So we're going to leave that just as is, minus ln of x minus 2, the quantity squared. And that, once again, would require distributive property or FOIL. At this point, I've got a log minus another log. I can condense those into a single logarithm. Since I have negatives, I'm going to have negative exponents, which means we're going to have a denominator. Anything on the top, basically anything that's positive like this term is going to be on top, so ln of x. Anything that's negative, so this term is negative, it's going to move this quantity to the bottom and make that x plus 2 the quantity squared. And then this one, we have subtraction, so that quantity is also going to be on the bottom. We're going to have x minus 2 the quantity squared. I am not going to FOIL that, so that's going to be our final answer for number 81. Number 83 uses the same idea. I'm going to distribute the 2 through each of these and make that 2 ln x minus 2 ln of x plus 1 minus 2 ln of x minus 1. I'm going to then carry the exponent up. Since we have natural log, I can treat that as an exponent. And I'm going to have ln of x squared minus ln of x plus 1, the quantity squared. I'd have to use FOIL or distributive property to simplify that, so I'm going to leave it. And then minus ln of x minus 1, the quantity squared. Using the same principle as the last one, these two are negative. They're going to simplify and be on the bottom. This one's positive, so it's going to be on top. We're going to have a single log with an x squared on top, and we're going to have on the bottom an x plus 1, the quantity squared, and we're going to have on the bottom an x minus 1, the quantity squared. And that is it, ladies and gentlemen. That's your final answer. Next problems we're going to look at, they want you to use, to simplify these without a calculator, and we're going to be thinking about power. So number 89, I'm going to do it because it's kind of gets us the idea of what the purpose behind this is. So log base 3 of 9, I'm trying to find that value, so let's call that y. That can be rewritten as 3 to the y equals 9. Put it in exponential form. Now, most of you right now would know that that y would have to be 2 because 3 squared is 9. No problem. At this point, I'm going to go ahead and show an extra step, and I'm going to think of that as 3 to the y equals 3 squared instead of 9. So therefore, y, or the exponent, would have to be 2, and I was looking for y. So my answer is log base 3 of 9 is 2. Okay? 91 is an extension of that. So 91, I'm going to think of this as y, and I'm going to say that 4 to the y equals 16 to the 3.4. Now, similar to the last one, I have for the y, I have 16 to some number. I have different bases, so I'm going to rewrite that 16 as 4 squared. Okay, now we're getting a little closer. I have 4 to the y, and my exponent rules say when I raise a power to a power, for example, x squared, I know is obviously x squared, but if I think of that as a power of 1 right there, that tells me I'm actually multiplying 1 times 2 to get my x squared. So when I have a power raised to a power, I multiply those exponents together. So I'm going to multiply those two exponents together, and I get 4 to the 6.8. So therefore, y, what we were looking for, has to be 6.8. Okay, so log base 4 of 16 to the 3.4 is 6.8. The last problem we're going to look at is problem number 120. What I like about number 120, gets us looking at these different graphs. And we're going to be comparing y equal ln of x, y equal n of x squared, etc. And most would just grab a calculator and try to graph, but I'm actually going to show you we can do these without any calculator at all and our knowledge of basic transformations. Now, y equal ln of x is that basic function, and all of these look like parent, it looks like ln of x is the parent function. So y equal ln of x squared, for example, can be rewritten, since we have a natural log, we can rewrite that as 2 ln x. Now, I know that y equal ln x, base e is saying e to some power is e to the y is x. So I know that when x is 1, y equal ln of 1 is saying e to what power is 1, y would be 0. So I have the order pair 1, 0. That's the common point. And 1, 0 is this point right here. So I'm going to say y equal ln x is either b or d. Now I know from experience with prior graphs that 2 ln x is going to stretch that graph vertically. So therefore, since b and d, one of them is stretched greater, d is going up at a faster rate, we can say that that the blue graph is ln of x, and that the black graph is 2 ln of x. It's stretched faster. 2 times 0 is still 0. It doesn't change that point, but it stretches all the others. So we've narrowed down those two. The next one we're going to look at is just ln of 2. ln of 2 is just a number, ladies and gentlemen. It's saying that e to some power is 2. And that is, since it's one value, y is just going to be some number. I know e is 1, or excuse me, e is 2.7. 2.7 to the first is too big. So we're talking about just a certain value, a little over 1 here, because we're trying to get 2.7 to some power and give you 2. So I'm going to say that a, the red, is just a horizontal line. And that, obviously, I could narrow it down that that one would be our C. But I'm going to go ahead and reinforce this for you. I'm going to take it a step further, and I'm going to say ln of 2x, pardon the disruption from the announcement. This is log of a product. I can write that as ln of 2 plus ln of x. And since ln of x is just that base function, our parent function, ln of 2 is just a number, that just shifts it, the ln of x function, up a certain value, specifically ln of 2. So that is the graph C because it's the original graph B shifted up, like so. Okay, so that allows us to narrow down to each of those. Good problems getting you thinking about graphs and how the properties fit into those.